And now for the third and final segment of the week one video, finishing up with earthquakes. We just ended talking about the intensity and the Mercalli scale. The other way you can measure an earthquake is by using what's known as a Richter scale. That's going to measure magnitude, which is the actual amount of ground shaking that takes place. And it actually is read off of the seismograph. The highest magnitude or amplitude of that wave is going to measure certain Richter scale, but it's not a linear scale. Difference between a 3 and a 4 is not one time as much, but it's 32 times as much. So when you start increasing between a 3 to a 4 to a 5, you start increasing exponentially, and it goes basically, if you were to have about a 10 magnitude earthquake, it would be catastrophic. So usually most earthquakes are going to be, even bad earthquakes are going to be between 6, 7, 8 on the Richter scale. Really bad ones get up into the 9. So if we want to look at the earthquake destruction or what comes from it, obviously there's a lot of factors. The first one be the structural damage. How much damage was done to the building or the structure at place, and that's depending on what it's made of. So it's not, there's a lot of factors. What about the intensity of the earthquake? How much shaking there was? How long did the shaking last for? So that's what duration means. The nature of the material of which the structure is rested on. If it's a nice solid granite, hard rock, you have less damage than if it's in more of a lot of soil versus a lot of sand. That's going to move the underlying material and cause it to actually fail. And then obviously the design of the structure could cause it to fail. So when we look at the destruction coming from the ground shaking itself, obviously that's going to cause liquefaction is what happens when an earthquake takes place in a sandy area, because basically it's like quicksand. As you start shaking the material, groundwater will move its way up and create, and it becomes a foundation that's very unstable for the structure that it's on. You get a tsunami, which is a seismic sea wave, or it's a tidal wave, as they will call it in the movies. And then because of the shaking, you can get lots of landslides, or if the surrounding area has a lot of pore space in the soil, it actually caused the ground to subside or actually sink. And then the last thing, because most gas lines are under the ground, you rupture those gas lines and you end up getting a lot of fires. So a lot of different destruction that can take place during an earthquake. Don't forget to look at the full PowerPoint, additional materials that I have within this slide. Obviously, I just did a brief overview. If you have any questions, feel free to email. It's mark.boer@addisonschools.us.